In this example, we're going to be looking at a magnesium atom. So we're going to figure out how many total electrons are in a magnesium atom, how many valence electrons. We'll look at what principal energy level those valence electrons are in. And then last but not least, we will give the most probable ion that is formed for this atom. So starting with magnesium, I'm going to start by writing its electron configuration. Now, you don't necessarily have to write out the electron configuration to figure out the total number of electrons, but it's going to help us answer the other questions as well, and I want to tie everything together. So a little practice with electron configuration. Remember, you always start at the 1s. So I'm starting in period 1. I hit the s block first. 1s2 brings me to helium. I'm done with the first row, so I go to the second row. I get 2. I hit the S block first. The max that can fit in the S's is 2. So 2s2 brings me to beryllium. Now I'm still in period 2, but I hit the P block next. And magnesium's not anywhere in the 2p block, so I want to go all the way through it. So it's going to be 2p6 is going to bring me to neon. Okay, next I go to period 3. I hit the S block first. And notice magnesium is right here. It's in the S block, the 3s block. Which one? The second one. So 3s2, that would be the electron configuration of magnesium. Now remember, when we talked about electron configuration, these superscript numbers represented the number of electrons. So if I add all those together, I'm going to get, what is that, 6, 7, 8, 9, 10, 11, 12? 12 electrons. So this is my total electrons. It's going to be 12. Now, since this is a neutral atom, it doesn't have a charge, that means that the number of protons is going to equal the number of electrons. So if you didn't want to write out the complete electron configuration, you could have just looked up the atomic number of magnesium, which is 12. And since this was a neutral atom, the protons equal the electrons, which would also be 12. So that's a shortcut way to do the total electrons. Okay, so now let's look at the valence electrons. So valence electrons represented by this VE, valence electrons. So for valence electrons, if you remember from reading in the book or watching the PowerPoints, these were the outer shell electrons. So when we're talking about an atom, we have the nucleus in the center with the protons and neutrons present in the nucleus, and then we have these rings around the nucleus in which the electrons reside. So when we're talking about valence electrons, they would be the electrons on the outermost ring. Okay, so only on the one furthest away from the nucleus. Those are the valence. So to figure out how many valence electrons magnesium has, there's several ways to do this as well. So one way is using the periodic table. So when we use the periodic table, when we talk about valence electrons for main group metals, which main group metals or main group elements, and main group elements would be the S block here and then the P block. So we're not talking about the D block, the transition metals. So it's the S block and the P block. So for main group metals, we said everybody in group 1 has 1 valence electron. Everybody in group 2, the alkaline earth metals, has 2 valence electrons. Everybody in group 13 has 3, 14, 4, 5, 6, 7, all the way up to 8. So this last column has 8 valence electrons, with the exception of helium, because these are the noble gases. We talked a little about the octet rule in the PowerPoints as well. And the octet rule says that all of the main group metals, or main group elements, want to have a full octet. So they want to be a noble gas. They want to have 8 valence electrons, just like the noble gases do. Okay, so using the knowledge that each row adds up to 8 with the final row, looking at magnesium, if I know where magnesium is on the periodic table, I see that it is in group 2, so that means it must have 2 valence electrons. So every element in group 2 would have 2 valence electrons. Now, when we're talking about valence electrons and referring to the electron configuration, the valence electrons, just like in this depiction, are the electrons on the outermost shell. So the highest energy level, furthest away from the nucleus. So when I'm looking at the electron configuration, it would be the electrons that have the highest principal quantum number. And the principal quantum number are these numbers here. So the highest principal quantum number would be 3. And notice in the 3s shell, we have 2 valence electrons. Okay, so that matches up. So we've answered the total number of electrons. We've answered how many valence electrons. Now let's answer what is the principal energy level in which those valence electrons reside. Well, from the electron configuration, we just said it was 3. When we talk about principal energy levels, remember what we're referring to are these numbers on the left side of the periodic table. These also correspond to the rings around the atom. We denoted principal energy levels using the letter N. So N is equal to 1, N is equal to 2, N is equal to 3, so on and so forth. So when we're looking at the periodic table, these are the N values here. When we're looking at an atom, this first ring would be the N equals 1 level. The second ring would be the N equals 2 level. The third ring would be the N equals 3 level. And if you added a fourth ring, so on and so forth. So the valence electrons, the electrons in the outermost shell, in this case, the outermost shell is the third shell, or the principal energy level 3. So we've answered the principal energy level question. Now, last but not least, let's look at what the most probable ion formed would be for magnesium. So this brings in a couple different things. So when we're looking at most probable ion, what we're trying to figure out is what charge is magnesium going to have on it. So is it going to lose electrons to become positively charged? Is it going to gain electrons to become negatively charged? So a lot of factors to look at here. First, we need to know where it is on the periodic table, and we figured that out. Now, what helps as well is knowing that it's a metal. So remember when we looked at the layout of the periodic table, we have this zigzag line that starts between boron and aluminum and continues down. And that zigzag line is separating the metals on the left side from the nonmetals up here on the right. Okay, so everything to the left of that line is going to be a metal. So magnesium, we then know, is a metal. And metals like to lose electrons. Why are they losing electrons? Well, this has to do with the octet rule. We said that all main group elements want to have a full octet. They want to have 8 valence electrons, just like the noble gases, because the noble gases are stable, they're happy. Okay, so what the metals do is they lose electrons to get the full octet. The nonmetals are going to gain electrons to get a full octet. So how do we know how many the metals lose and how many the nonmetals will gain? Well, let's add another column here. So in blue above for each of the groups, we have the valence electrons, 1 through 8 for the main group metals. We can also do this for the charges. So group 1 likes to always form a +1. Why? Because they have 1 valence electron and they like to lose that 1 valence electron. When they lose 1 valence electron, they become positive. Group 2 is going to form a +2. Because they have 2 valence electrons, they lose both of those valence electrons to become a +2 ion. And since magnesium is in that group, the most probable ion for magnesium is going to be +2. So we've answered all the questions for this particular problem. However, I want to go through this side and give you the charges or the most probable ions that those groups form. So aluminum is usually +3 because that's a metal. Even though it's right along the zigzag line, it's still a metal. Group 14 here, it can be either a +4 or a -4. So that's a tricky one. Looking at group 15 with nitrogen, phosphorus on down, they like to form a -3 charge because now we're looking at the nonmetals, and nonmetals like to gain. So if nitrogen, so let's use nitrogen as an example, say it has 5 valence electrons. That's what this number in blue is telling me. Well, it wants to have 8. So if we add 1, 2, 3 more electrons to nitrogen, it will have 8, and it'll now be happy. It'll have a full octet. Well, when nitrogen gains 3 electrons, since electrons are negatively charged, it's going to form a -3 anion. Oxygen, since it is 2 away from getting a full octet, it's going to gain 2 electrons to become a -2 anion. The halogens in group 17 here will form a -1 charge because they are 1 away from getting a full octet. So the challenge for the discussion this week is for you to pick one of the main group elements. And there's more than this. I just didn't draw the whole periodic table, so it can be anything further down as well. But choose one of the main group elements, give the total number of electrons for that neutral element, give the number of valence electrons for the neutral element, tell me what principal energy quantum level those valence electrons are in, using the numbers on the side here. And then last but not least, tell me what the most probable ion would be for that particular element.